Let's run through an example of using units as a problem-solving strategy. Specifically, what we're going to do here is write out all of the units as we're solving a problem in order to guarantee that we're on track as we're proceeding through the problem solution. So let's just imagine a physical scenario where you're in your car driving down the road at an initial speed of 3 meters per second. Let's say you then press the accelerator pedal in your car, and you're going to press the accelerator pedal for 2 seconds, and you know that you're going to accelerate at a rate of 4 meters per second squared. Let's say you want to be able to calculate what your final speed is going to be after that duration of time. Okay, so how you can go about solving that is using this kinematics equation. More on where that comes from in future videos. But for now, if we're just interested in solving for VF on the left side here, what we need to do is plug numbers in on the right side over here. And let's see how doing units can reassure us that we're proceeding through this process correctly. Okay, so let's just take our numbers from here and substitute them in on the equation over here. So let's imagine that we go through this, and it's very tempting to do this where you just plug in the numbers without including the units. All right, so you'd get a number out of that if you solve that. But it's kind of ambiguous as to exactly what you calculated. Right? So let's erase that. And let's start from this step here, where this time we're going to include the units. Right? So our initial speed was 3. We're now including meters per second in line as we're proceeding through this problem, plus our acceleration of 4 meters per second squared, multiplied by the duration of time of 2 seconds. Okay, so now because we've included the units in this problem, let's go through and do the algebra for each part of this calculation while including the units. So for our first term right here, what we have is, let's just rewrite that as 3 meters per second. But in the next line here, let's multiply our numbers that we have together. So if we multiply 4 by 2, we end up with the number 8. But what is the unit associated with that 8? Okay, so let's look at what we have here. We have units of meters in the numerator, and there's no other meters anywhere in that term. So whatever unit accompanies this 8 is going to have meters in the numerator. And then let's look at seconds. So in this term we have seconds squared in the denominator, and then in the time term we have seconds in the numerator. Okay, so what that is seconds divided by seconds squared, and that gives us units of 1 divided by seconds. Okay, so let's just take that and put seconds in the denominator there. Okay, so let's look at what we have here. We stumbled upon an important property of units, where we're going to add a number with units of meters per second to another number with units of meters per second. Whenever you find yourself adding numbers with units together, the units of both terms have to be the same. If you find that you had something that looked like this, something, imagine meters per second plus meters per second squared, you would have raised a red flag that you've done something that's not representative of how the universe works. And you would have identified an error before getting to the end of the problem. Okay, so that's red flag number 1. You should always be adding things with the same units together. So this is good. All right, so the next step is, let's just add the 3 plus the 8, we have 11 of our unit of meters per second. Okay, so what we were calculating there was the final velocity of our car after this acceleration process. Okay, so now we have another sanity check that we can use. We've arrived at an answer. We have an answer of 11 meters per second. Well, is the quantity that we were seeking, the final speed, is that something we would expect to have the units that we actually got from the right side of our equation? And the answer in this case is yes. You would expect meters per second on the left to equal meters per second on the right. Anything other than having the same term on the left and the right is going to indicate that you've made a mistake somewhere, and you can capture that error using this method. Okay, so using units as you proceed through the problem solution, as we've done over here, is just a valuable way of ultimately saving yourself time and hassle by ensuring that the process that you're carrying out is correct.